Welcome students to the solution of problem sheet 4. This is the first question of this problem sheet number 4, where this particular question says that it is a 2 degree of freedom system where we need to find out the two natural frequencies of vibrations and the ratio of amplitudes of motion of M1 and M2. For the calculation purpose, the numerical values of M1 and M2 are given, as well as spring stiffness K1 and K2 are said to be equal, and they are equal to 40 Newton per meter. Now this is the free body diagram of the question figure, which shows the spring forces acting on the masses M1 and M2, where we are assuming that x1 and x2 be the displacement of masses M1 and M2 respectively at any given instant of time. Based on Newton's second law of motion, which is summation of forces is equal to m into acceleration, for the first mass we can write the equation like this. The summation of forces m into acceleration is equal to summation of the spring forces. The plus and minus these signs are according to the directions of the spring forces shown in the free body diagram. Let us simplify that equation to reach this stage of equation 1. Similarly, for mass m2, we are writing this equation of Newton's second law of motion and simplified that equation to reach the equation number 2. The solution for x1 and x2, now let us consider this displacements to be harmonic vibration, and hence x1 is taken as x1 sin omega t and x2 as x2 sin omega t. These are the common form of harmonic vibration or simple harmonic motion. So differentiating these displacements x1 and x2 twice, we will be getting this acceleration as minus omega square x1 sin omega t and minus omega square sin x2 sin omega t for the second displacement. Now using these equations 3 and 4 into the equation 1 and 2, we will get these two equations 5 and 6 in this particular form. Here the difference is only we put the values of x1 and x2 into the equation 1 and 2 and the values of acceleration into the equation 1 and 2. Now from equation 5 and 6, we can find out the ratio of amplitude which is being asked in the question to find out. Now the main important concern of you all is that both these two equation of amplitude of vibration or ratio of amplitude of vibration is actually similar. Whenever you will be putting your numerical values into this equation 7 or 8, you will be getting nearly same values as the answer. I'll show you this at the end of this problem. Now equating equation number 7 and 8, we can find out a relation between all these parameters m1, m2, k1, k2 as well as the omega, which is the natural frequency. Now this equation number 8 takes a form where the order of the equation is 4 or degree of the equation is 4 actually. So to simplify this equation, we can consider omega square is equal to lambda, and then this equation number 9 will take a form like this, which is a simple quadratic equation. Solution to equation number 10, which is lambda is equal to minus b plus minus root over b square minus 4ac by twice a, which is a simple solution of quadratic equation and a very famous solution and known to all of us. So in this way, we can find out the value of lambda from the equation number 10, where lambda was equal to omega square. So putting the values of k1 and k2, m1 and m2, we can now find out the value of omega square from the lambda, and taking the square root of the values of lambda, we can find out the value of omega 1 and omega 2. We will be getting these two values omega 1 and omega 2 because here minus b plus minus root over b square minus 4ac. So because of this plus minus sign, for plus we will be getting one value of omega, for minus we will be getting the next value of omega. Then substituting these values of omega 1 and omega 2 into the equation 7, we can find out the amplitude ratio as minus 0.765 and 0.696. As I was saying in the previous slide, this particular ratio you can take from the equation 7 or equation 8. It doesn't matter because the final answers will be nearly same to these two values. So whatever you want to take, either equation 7 for calculating the amplitude ratio, you can take equation 7. If you want to go for equation 8 to calculate this amplitude ratio, you can consider equation 8 for your final calculation. Both these two equations 7 and 8 will finally result into the nearly similar answers. Thank you.